Hello everyone, in this video tutorial, we will see how we can create a vehicle's intensity heat map using YOLO-NAS. So this is a complete end-to-end video tutorial. Don't skip any part of the video and let's get started. So here you can see that I have created a folder by the name Vehicle Intensity Heat Map for this project. So first of all, I will open PyCharm and create a new project over there. So I have opened the PyCharm. So I will go to File and click on New Project from here. And here I will just select the directory of the project. So I will just select this folder which I have created in my D directory into. So I will just select this folder and this location matches. And we are using Python 3.10 as base interpreter. So you can see the details over here. And so I will now click on create the new project from here. So now it's creating a virtual environment. Along with this, it will update the interpreter paths as well. So this all might take few minutes. So it's updating the interpreter part and it's ready. So that's good. So now, first of all, you can see that I'm just create a, so now you can see that we have created a project over here. I will just do a right click and click on new, and we will just create a file by the name requirements.txt. In the requirements.txt file, I will list all the required packages that are required in this project, which include super gradients package and OpenCV Python package. So in the requirements.txt file, I will list all the packages that are required in this project, which include super gradients and OpenCV Python package. So I will just go to the terminal and just write over here pip install -r requirements.txt. To install these two packages, I will just write in the terminal pip install -r requirements.txt so that we can install these packages. To do object detection in the YOLO-NAS, we require the super gradients package, and you can see that here I'm installing the super gradients package, and here is the version of this package which is listed over here. Now in the next step, what I will do is I will just click over here and create a .py file in which I will write all the code for this project, and let's write vehicle intensity .py. In the first step, I will import all the required libraries. So I will just write over here import CV2 pack. So I'm just importing OpenCV Python package using import CV2. OpenCV Python package help us to read an input video or an image or display the output video. Plus, it also provides different image processing functions as well. We can blur the image using cv2.blur function. We can apply Gaussian blur using OpenCV Python Gaussian blur function. We can create bounding boxes or rectangles around the detected object using cv2.rectangle function. We can also add the label over the object using cv2.put text function. Plus, we can also reduce the size of the text using cv2.getTextSize function. So in this project, we will be using OpenCV Python package extensively. It is used to pre-process the video image. So it's a very important package and we must require this package. And the other is, so from the super gradients package, I will just import models. I will just write from super gradients dot. So it is from super gradients dot training import models. So next I will just import NumPy package. We will require the NumPy package when we are creating the vehicle intensity heat maps. Okay, and the other package which I require is math package. I will use math package when I will be calculating the confidence score. So next, the last package which you require is import torch. So if we have the CUDA available, I will be using GPU, or if you have the GPU available in our system, you will be using GPU. But as I don't have the GPU in my system, I will be using CPU. Thus, I will be doing or applying vehicle intensity heat maps or creating vehicle intensity heat maps on some videos. So I will just create a directory by the name video, and I will just add some sample videos into this directory. So let me just go towards this folder and add some videos over here. X1, X2, Y2, and here I will further write B box 0, B box 1, B box 2, B box 3. Okay. So here we have got the bounding box coordinate, but this output is in the form of tensors. Let's convert this output from tensors into integers. Okay, and so now we have converted the output from tensors into integers. Plus, we will also calculate the class name, which is over here, and it will be class name. I'm just calculating over here, and the class name will be okay. And so whether this belongs to the bicycle. So from here we get the value in the form of integer. So if it is class is this value is 0, that means that the rejected object belongs to the person class. If the value is 1 over here, class name value is 1 over here, it means the object belongs to the bicycle class. And if the class name value is 2 over here, it means the object belongs to the car class, or directed object belongs to the car class. And if the this value is 80, this means the object belongs to the toothbrush class. So let's go ahead and now we will calculate the confidence score. So to calculate the confidence score, I will use math library, which we have imported above. And here I will just write down. So here I'm just calculating the confidence score, and the label we have class name and the confidence. Okay, so this look good. Now here I will be just calculating the frame count. We'll be doing the frame count over here. So I will just write over here count. So I have not initialized the count over here. So I will just write count plus is equal to 1. Okay. So here I will just write this, and then we will just write x1. So x1, x2, y1, y2. So I'm just printing the bounding box coordinates values into my terminal. So now in the next step, I will just calculate the text size using cv2.getTextSize function. And here I will just write font scale 1 and thickness will be 2. So that's look good as well. And now further I will just write t dash size 0 y1 plus t dash size 1 minus 3. So this looks good as well. Just update this, there will be minus. So this all looks good now. No, there should be plus here as well. Okay, so that's look good. So now what I will do is I will just create a rectangle over here. So now we will be drawing bounding boxes around the detected objects using these coordinates, and I will be using the cv2.rectangle function to draw bounding boxes around the detected objects. And the bounding box color will be, okay, so the bounding box color will be blue. So I will just write here blue color. So I have just written the RGB code for the blue color, and the bounding box thickness will be 3. Okay. So now I will also create a rectangle above the bounding box using cv2.rectangle function. And here I will just write x1, y1, over here c2. And over here I will just write, okay, so that's so good. Plus this rectangle will be filled. So I will just write cv2 dot line dash double A, because we will just fill this rectangle and just add the text, which the text will have the label and the confidence score. So to add the text, I will be using cv2 dot put text function. And here I will just write the coordinates where we want to add the text. And here I will write x1, y1 minus 2 over here. And further, I will be writing 0, 1. So I'm just defining the font scale and other parameters over here. And the text color will be black. Okay. So we will just set the text color to be black. You can see over here. So I've just defined the RGB value of black text color over here. And the thickness of the text will be 1, and the line type will be cv2.line dash double. So we have defined the thickness, we have defined the line type now. So we have done it. So let's end this. So first of all, we will only see how we can detect objects using YOLO-NAS. Then we will do the vehicle intensity heat map as well in the next part. And here I will just write, okay, so we need to resize the frame as well, because I think this might create an issue if we don't resize the frame. So we will also resize the frame over here as well. So to resize the frame, I will use cv2.resize function to resize the frame. So I will just write over here resize frame, and here I will be using cv2.resize function, and the input will include frame. And here I will define the scaling factor over here. So here you can see that I have defined the scaling factor over here. And further, I will just add the interpolation over here. So I will just write cv2 dot, for interpolation, I will just write over here cv2 dot inter dash area. So now I have defined resize the frame, because if the frame size is large, then it might not be able to fit into the screen. So we have just resized the frame over here. Okay. Next, what I will do is I will just save the output video by writing out.write frame over here. Okay, and if cv2 dot wait key 1, so if user press the wait key, our program will just exit from there. So I will just write, okay. So if the user press the one key, the program will break. And in any case, if we don't have the video or if the video path is not correct, then the program will also break. So that's all from this. So now further what I will do is I will just write out.release. So cap.release from here. And I will just write cv2.destroy all windows. So after this, our program will be ready. So let's see how does it go. So I think it will work fine. I am hopeful, but if there is any error, we will fix it up. But let's be hopeful and let's execute the code and see what output do we get. So I'm just running this. The name of this file is, okay. So instead of if I just enter the wrong name, so let me just copy this. So let's see how does it go. So I've just started executing the script. So this might take few minutes before it starts to execute, and let's see what results do we get. So it has started to executing. So this will take some time. Okay, so you can see that I'm not able to see the output video because there is a mistake which I have made over here because I have not defined the cv2.im show function. So let me just correct my mistake and just write over here cv2.im show so that I can just display the output video, or just write output video, and here I will just write resize frame. So now we will have the output. We will be able to see the live output over here. So let's execute it and see what results do we get from here. So I've just started executing the code. This will take some time, but let's see how does it go. So, okay, so let me just show you the output. There is a mistake, so we need to fix this up, but let me just show you the output first. So you can see that we have bounding box around the detected objects, but this should be above here. So that's not correct. So let's just correct this out. Let's go back to the code and let's just figure this out. I can see two mistakes over here. First is this one mistake, and the other is basically I just need to add this because we just want to add the name. We just not if we just add it, this will give us the ID like this 01. So 0 belongs to the person class, but I just want to add the name of the class. So I have just corrected this and let's execute it again. Hopefully it will work fine. So let's see how does it goes. But if there is any error, we will definitely fix it up. So it has started to execute and let's see what results do we get from here. Oh, so let me just show you the output. There is a mistake. We will just recheck it. So now you can see here, there is still a mistake. So let's go back and just fix it out. Okay, so what I feel that this is the mistake over here. So I think now it should be fixed because I don't see any mistake else than this. I think this is the only mistake which I have found out. And I think after this, there should be no mistake. So let's execute it again and let's see how does it work. So I'm just executing the script again. I'm hopeful that it will work fine now. But if there is any error, we will fix it up shortly. So it has started executing and let's see. Okay, so it's fine. Let me just share the output video with you. So now here you can see the output video. You can see that we are able to detect the object. Plus we have created a bounding boxes around them. Like this is car, this is car, this is car, this is truck. These are all the cars and these are the two trucks. So the detection results look impressive. So till now I'm very satisfied with the results. And these are very good results. For now, the results look very impressive. Okay. So you can see that we are able to detect the car, truck. So let's go back and let's add the vehicle intensity heat map code over here. And let's do it now. So, so now I will just add the vehicle intensity heat map code over here. So first of all, I will just initialize a variable. So over here, so I will just write over here, global image array is equal to none. So I've just initialized this variable over here. So now what I will do next is I will just calculate the width. So this is the one way. In this way, you can also calculate the frame width and frame height. This is the correct. There is another way in which you can calculate the frame width and frame height. So I'm just trying to also tell you this that way in which you can calculate the frame width and frame height. So I will just write over here in cap.get because we have saved this our video in the variable cap. So I will just write in cap.get over here and I will define cv2 dot cap dash proportional, and here I will just define the frame width first. So now you can see that here I've just defined the frame width, and now I will just add the frame height over here as well. So now you can see that here I've defined the frame height. So now you can see that we have defined the frame width and the frame height. So this is good till now. We are able to find the frame width and the frame height. So you can also write it, print it. So now when this program executes, we can see the frame width. And here you can write print frame height. So you can see the frame height over here as well. So after defining the frame width and the frame height, I will just go over here and just write global image array is equal to np.1. So I will just create an array of ones, and the size of that ones array will be as per the height and width of our frame. Okay. So that's good. And the data type will be okay. So far so good. So next, let me just print this. So we can also see what is this. Okay. So now we are just creating a vehicle intensity heat map over here now. So that's so good. And just right over here, dot shape. So to find the shape, we will use the dot shape function. So that's low code as well. So that's all good. So for now, we are very on a safe path. So we have defined a global image array variable, and we have just keep that variable with the, we have just created an array with respect to the height and width of our frame. Ones array it is, okay? So it should be np.ones over here. So that's look good as well. So we have created a ones array over here. So now we will just go down and start doing the code over here. So just press enter over here and just start writing the code. So I will just call the global image NP array, which I have created over above. And in this array, we will just pass the coordinates where we have the bounding box. So we will pass the coordinates of the detected object or the bounding box over here. Okay. So as you can see that this is the ones array. So now you can see that we have created a numpy array of one. So wherever we have the detected object, we will just increment the count of the ones we have in the array. So this is the numpy array with the ones, and the size of that numpy array is as per the height and width of our frame. So now I will just do the increment in that array with +1 in every frame when we detect an object over there. Okay. So that's so good. So let me just go right over here. Global image array after while. So we can also see that how it does look like, and just copy this and just print this over here. And just copy this as well and just write. And just write over here dot shape. So still now we have done good, and I don't see any error from now. So next what we will do is I will just write dash norm over here, and here I will just define okay. So that's look good till now, and I don't see an error for now. And now I will just change the as type to int 8 over here. So now I'm just changing the as type over here to int 8. So this looks quite good till now and don't see any error. Okay. So now in the next step, I will apply the Gaussian blur and draw the heat map. So we apply the Gaussian blur to remove the noise from the image and to reduce the clarity of images. And plus we also want to blur the images. So we apply Gaussian blur to reduce the noise from the images, reduce the clarity of the images, and the blur the images. Okay. So to apply Gaussian blur, I will use a cv2.Gaussian blur function. Okay. So I'm just defining cv2.Gaussian blur over here. And here I will just pass the frame over here. And here I will just write over here, or just pass the over this over here. And here I will just define the kernel size 9 cross 9. And here I will just define the, you can say the max as auto. For sigma, here basically we set the sigma as auto. So auto means 0, and I have just set the kernel size value 9,9. So kernel size value will always be in the odd numbers. Okay. So now in the heat map, we just need to define the color map of the heat map. So I will just write cv2 dot apply color map. And here I will just write okay. So, and the color map which I am choosing is jet. Okay. So let me show you other color maps as well. So we have different color maps available. So I will just show you the list of other different color maps available as well. So let me just navigate my screen and show you other different color maps available. So I will just write cv2.color map. Okay, let us. So here I've just click on the color map in OpenCV, and if I just go below, so you can see that I am just applying the color map jet over here, but you can see the color map bone, color map Ottoman. So there are variety of color maps available as well. You can choose any of the color map from here. Okay. So in the color map jet, we have these colors. Okay. So our height map will have these colors. So just remember, so our heat map will have these colors. So till now, good. And we have applied the color map over here as well. And next, what we will do is, so now you can see that we have applied the heat map. So now I will just overlay this heat map on the video frames, or you can see that using cv2.add weighted functions, I will just blend the images. So I will just overlay these heat maps on the video frames, and cv2.add weighted function, I will just uh, blend the images. Okay, so I will just blend the heat map image with the frame, original frame. So just write superimpose image, and here I will be using cp2.add weighted function over here. So here I will just define heat map image, and blending ratio is being kept as 0.5 over here. So this looks good. And I will just write over here out.write is equal to superimposed image over here. And in the CV superimposed image will be also be passed over here as well. And okay. So let's see how, let's execute it and see what kind of output we get. Usually in the first try, we always face errors, but let's see how does it goes. So it has started executing, and let's see how the things work out. As usual. Before I just go to the error, you can see that our frame width is 1920 and frame height is 1080. Okay, so you can see the frame width and frame height. Okay, so where is this error? Okay, so we are just defining the global image array over here, and this is np.uint. So this should be uint. Okay, I've just defined this below as well. Let's execute it again. And let's see how does it goes. So this might take few seconds before it executes. And let's see what results do we get. Okay, it has started to execute, but error. cv2.add weighted function. Error is cv2.add weighted function. Let me just check this function. Okay. And everything else looks good. So let's execute this. So this was the key argument missing in the position number 5. So I've just added that argument, and let's see how does it works. Okay. So before we go ahead, let me just show you the output image. So let me just explain the key thing over here. Okay. So now you can see that we are just creating a NumPy array by in this form. Okay. Okay, let me just terminate this process over here. Okay, let me just explain you something. Okay, so now you can see that we have the frame width and the frame height. Okay, so you can see if I just go over here, so you can see that we are just creating a global image numpy array over here. You can see, so this is the n numpy ones array, which you can see over here. And you can see that we have just defined the this shape as global image numpy arrays height and widths. Okay, so as we have a frame height 180, so you can see the 180 over here and the frame width 1920 over here. You can see it. Okay, so if I just go ahead, so you can see here as well, if I just go below down, we are just where we have the bounding boxes in the global image array, which we have created over here. I'm just adding one. Okay. So you can see that here we have created a global image array with the ones, and where we have the bounding boxes, you can see I'm just adding ones over here. Okay. So let me just show you. If I just go below, so currently in the start, we don't have any change. So let me just execute it and see. So let me just share my screen and show you the output video. So now here you can see the output video over here. Okay, let me just. So now you can see the output video. So you can see that over here, we have more cars over here. Like you can see, so you can see the intensity heat map over here largely, while you can see here, they don't have very much cars over here. So you can't see the impact of vehicle intensity heat map over here much, but you can see over here, there are multiple cars over here. So you can see the more impact of vehicle intensity heat map over here. So now you can see that we have created a vehicle intensity heat map. So the results look good. Like you can see over here, we have got some good results over here. So you can test it on multiple other videos as well. So you can see that there is not very much load of traffic on this lane. You please see the cursor on the left lane. So you can see that we don't have very much intensity heat map over here. But on the right lane, you can see that we have very much load of traffic. Like you can see many cars are passing over here in the right lane. So you can see the intensity heat map over here. So you can see that in the right lane, multiple cars are passing. So you can see the impact of intensity heat map. Like you can see that in the right lane, multiple cars are passing. So you can see more impact of intensity heat map in the right lane. You can see like as many vehicles are passing over here. So you can see more impact of intensity heat map in the right lane. So if I just go back to the code, so now you can see that as we are incrementing plus in the global image array over here, so you can see that these values are changing. So whenever we find detected object in the frame, we just increment one. So now you can see these values are increasing. Okay. So you can see these values. So that's all from this video tutorial. I hope you have learned something from this video tutorial. See you all in the next video. Till then, bye bye.